In this video, we're going to talk a little bit about some of the precision measuring tools that are needed in the machine shop. As we start to get into writing programs in Mastercam and we're starting to build these parts on the CNC machine, we need to be able to verify that we are building the part correctly. And precision measurement dates back to the 1800s, where engineers started to realize that we needed some system of consistency between one part of the country to the other. And in order to do that, a standard was developed. And I have in front of me a set of what are known as gauge blocks. Gauge blocks are a standard of reference. These are precision made, lapped to a specific dimension. And this set of gauge blocks is certified to that level of precision, identically to the same set of gauge blocks that's in Europe, that's in the Northeast United States, everywhere in the world. Now there may be metric or US versions of these gauge blocks, but they're still going to be calibrated the same way. And it gives you the assurance that your part is going to be made to the same exact size as someone halfway across the world. So let's talk about the basic hand tools that you as the machinist would use whenever you're checking your part. One of the most common is the dial caliper. And we're going to talk about that in just a second. But first, I want to talk about the first type of caliper that was developed, and that is known as the vernier style caliper. Okay, this is the vernier style caliper. And as you can see, it has a very interesting layout in how you read this tool. Using this layout, you can actually measure within 1/1000th of an inch. We'll get into talking about that at a later time, but this particular type of caliper is one of the first calipers that was developed and is still used today. However, you have to have a magnifying glass many times to see those little bitty lines. And you don't see machinists using them too often these days because we have the advent of dial calipers and digital calipers. The one positive to a set of calipers like this is the fact that they last for 100 years. And they're virtually indestructible. They're really, really nice. Okay? Alright, so let's take a look at these dial calipers. The dial calipers are set up where they have a dial that goes from 0 to 100, and that each increment in that dial is 1/1000th of an inch. So if we look at this pair of dial calipers, you can see that there's a scale that goes along the beam. That scale, let's take a look at that. That scale is in hundred of thousandths of an inch. So each one of those tick marks is 100 thousandths, or 0.1, or 1/10 of an inch, however you want to say it. So if we look at this one right now, you can see that we are at 0.2, and then we look at the dial, and it looks like it's a tick before 60, so we're at 59, so we're at 0.259 as a dimension here. So let's try another one. We'll stop right there. I can see the 0.9 on the beam, and I'm about 1/1000th past the zero, so I'm at 0.901. Let's do one out here further. We'll stop right there, and I can see my 3 inches mark, and then I can see my 0.2 mark, and then I look over at the dial, and it is at 0.048. So this dimension would read 3.248. And it's as simple as that. Okay, so let's talk about the type of measurement that you can do with this tool. I'll turn this camera back to autofocus here. All right. Here's a part that I made, and if I need to measure the outside diameter of that part, I would reach out to the outside of those jaws. And one thing you'll see me do is I place the part as far back into the jaws as possible to prevent flex. Okay, and if we were to read that, it looks like I have about 0.495 as a dimension on the OD of these threads, which is a pretty typical dimension for the OD of a 1/2 inch 13 thread. Okay, now let's say that I need to measure that little relief cut there. Okay, well, you can do that with calipers too. We can get in there and you can see how these jaws are tapered. I can get in there and I can take a measurement of that as well. For that little relief, it looks like I machined that to 0.386, something like that. Okay. You can measure the length of a part very easily. Okay. And another little added bonus with the calipers is this little depth tool. I can use this little depth tool to take depth readings as well. Okay. Now let me show you one additional feature that's just too cool. Let's say that we need to measure the ID of the hole in this part. I can use these jaws, which are known as our ID jaws, to actually measure the ID of that hole. There we go. So as you can see, calipers have a variety of uses. They even have a little secret use behind the jaws. This is known as the step measurement. Here, see if I can get you a shot of that. And that's useful. Very similar to how we use the depth rod. Take a measurement like that and you should get the same measurement that we got whenever we were using the depth rod. So a very useful tool. Now you might be wondering, okay, I like that. A 0 to 6 inch pair of calipers has a 6-inch range. It covers a lot. Why would I not use the calipers all the time? And the reason is that the dial calipers are only accurate to about 1/1000th of an inch. I would say plus or minus 1/1000th of an inch, giving it a 2/1000ths tolerance range. This is good for most work because most of the time you're working with tolerances that are larger than that. But in the event that you're working for a press fit or a bearing fit, something high precision, say the crankshaft of a vehicle, you're going to need to be within 1/10ths of 1/1000th. And that's when you would transition to the micrometer. And I've got 3 different micrometers here. I have 2 standard vernier style and then I have a digital pair as well. The micrometer is approximately 20 times more accurate than the caliper. And that's based upon the design of the tool. There are folks that can use a pair of calipers and get a dimension identical to what someone that's using a micrometer would get. But in general, the design of the tool lends the micrometer to about 20 times more precision. As you can see with the micrometers, you also have a very short range. This is a 0 to 1, this is a 1 to 2, and this is a 0 to 1 as well. So you would actually need 6 micrometers to have the full range of the 6-inch calipers. So in another video, we'll talk about how to read the micrometer. I'm going to show you real quick a little tip that I have for testing yourself when reading calipers, and micrometers for that matter. But one of the hardest things to do whenever you're learning how to read calipers or micrometers is to learn how much pressure you should apply to the anvil. And I'm always asked, well, how hard should I squeeze this caliper to get the reading? Because the harder I squeeze, it changes the dimension. And the answer to that's very difficult because my interpretation of Well, not too much, may be different than somebody else's interpretation. So I have a foolproof method. Take your calipers and get a set of generic gauge blocks. They're not that expensive, and the school has a set that you can use. Take a gauge block. Don't look at the size of the gauge block, and then take a measurement. Okay, so I got 0.19. I'm going to then look at my gauge block, and sure enough, I don't know if you can see that in the video, but this is a 0.19 gauge block. Now that I know that this is the size of the gauge block, I'm going to consistently check myself to make sure that I can get repeatable measurements every time I grab that gauge block. And when I can do that without even trying, I'll skip over to a different gauge block. I won't even look at it. I'll just grab one and I'll check it. And the goal here is that you start to develop a feel for how much pressure to put onto this tool so that you get the correct amount of pressure and the correct reading. Here's a gauge pen. This is another useful tool for doing this. This is a 0.423 minus, which means that it's a couple tenths under 423. And there you go. The needle's just below the 3. Okay. This same technique will work with micrometers, and it's actually even a little more useful whenever you're learning how to use the micrometer. And what you'll do is you'll just repeat this so that you can ensure that you're getting the same amount of pressure each time. Okay. As I said, we'll talk about the micrometer in another video soon, but this gives you a basic outline of some of the precision measuring tools that are needed to make sure your part is machined to specification. Thank you.